Good afternoon to all of you.
Good afternoon, sir.
Good afternoon.
Sir.
Good afternoon, sir.
Okay, so in the previous lecture, we discussed about how time of travel is recorded. Okay. So when the receiver transmits a laser pulse, then at what level or at which particular time when the signal start from its zero value to peak value. This is the peak value if you see in the figure, and this is the zero. So 0 to peak and then further peak to 0. So
Sir,
at which
screen is not
Screen is not.
Sir, screen.
please wait, I think I have already. Okay. Okay, so I hope now you can see the screen.
Yes, sir.
Yes, sir.
Okay. So in the previous lecture, we discussed about how the trigger signals are generated to send a command to the counter circuit to start the counting and to stop the counting. Okay. So here, as you can see over here, like this is the pulse, energy pulse that is generated by laser transmitter. So it's a zero value, then it attain its peak, then again come back to the zero. So at which particular time we trigger, that trigger signal is generated for the counter to start the counting. And we have also seen that like the same process we adopt when the return is received at the receiver end. Okay. So if this is the shape of the return signal, so again at at a particular time, we need to when it is received by the receiver, that energy level is identified by the receiver. Then a trigger signal is generated for counter to stop the counting. Okay. But what we have seen that in a constant fraction method, like in this case, you see, we have discussed about constant fraction method where we select a particular threshold level. So this is the threshold level. Okay. And this level intersect at a particular time at the rising end. Okay. So when the receiver analyze the return signal, so here through our discussion we have seen that the shape of the return signal varies with respect to the like what kind of object is there at the target and what is the topology at the target. So as you see over here, it's a transmitted laser pulse. Okay. And this transmitted laser pulse, when interact with the target, let's say somewhere here we have a target point P. Okay. So the shape of the return pulse depends on what is the topology over here, whether it is a flat surface, it is inclined surface. Okay. And what is the reflectance? Okay, so what is the geometrical property of target point P as well as what is the radiometric response of a target point P? Okay, so when we talk radiometric response, what is the reflectance? Okay. So what is the reflectance and whether it is slopey terrain or it is flat terrain? Fine. So there is a change. The way this energy pulse interact with the object, the shape of the return changes. Okay. If it is a slopey terrain, topology varies in that way. So there is in the return signal, you can see the broadening in the shape, like over here. So when we use a constant fraction method, so what do you need to do? When this energy is received at the receiver, a threshold level is defined. It's a VTH. Okay. So at this VTH level, when that energy starts entering to the receiver, when it attains this VTH, let's say if we considering this return pulse, so at this point, a trigger signal is generated to stop the counting. Now, see, the shape of the pulse changes in the second case. And at longer duration, the trigger signal is generated over here. Further, again, the shape of the pulse changes and the trigger signal is generated delayed compared to the first one. Okay. So you can notice over here the time of travel that is recorded in the case of first, second, and third. You can see the increment in the time of travel. And this is called as range walk. Why it is range walk? Because the range keeps on increasing due to delay in the generation of signal, trigger signal to stop the counting. Though all these three returns are generated, maybe there are 3 points, but their distance from the transmitter is same. Like somewhere here we have a transmitter. Okay. And let's say we have a 3 points over here. Okay. So this distance D, all distance is equal D. But let's say from this target, the generated pulse is this one. The return pulse is this, while for this and this the flat we have this. Though distance is same, but there is error. Okay, and this error is called the such kind of error is termed as range walk. Okay, so this range is increased. It's maybe D plus delta D. Similarly, this is also D plus delta D. And this delta D is due to delayed in the generation of trigger signal to stop the counting. Do we have any method to apply this correction? What kind of correction I am talking about? How we can correct this delta D, the incremental distance, which is added up with actual distance D, how this can be corrected? Okay. So we'll see it.
Sir, this delta D distance is from where to where it is?
From where to where it should be?
So from a normal peak of the face to the lowest one.
Delta D is the additional distance that is due to error in time measurement. And D is the ground truth. D is the actual distance, that is ground truth. And delta D is the additional distance due to error in time measurement. And why there is error in time measurement? Due to range walk. Okay, so how we can able to correct it? Okay. Sumit, is it clear or I need to repeat it?
No, sir, it is clear.
Okay, good. So how corrections can be implemented? What we do, we assume the shape of return echo is it is, we call it rectangular. Fine. Okay. This is the ideal case we consider, like shape of the return is the rectangular pulse. Okay. And this is the point at the rising edge where trigger signal is generated. Fine. But what happened? In a practical case, the shape of the return pulse is not rectangular, rather it's a Gaussian. Okay. See, if transmitted and return is again, quickly I would like to discuss over here. Let's say this is a transmitted pulse, and the same way we have the received pulse. So just see, rising edge is a impulsive in nature, while falling edge is also impulsive in nature. It's not a gradual change. Okay, it's a sudden change from 0 to peak in time delta t is equal to 0. Similarly at this ways. Okay, so in this case, no range walk. Because see, when this pulse is received, so it's a very impulsive change you can see. So whenever it enters to the receiver, a trigger signal is generated. So there is no problem in this case. So this ideal case we consider over here. And so a VTH level is defined. So this is level VTH, threshold level. If we consider the ideal case, then at this particular point, trigger signal has to be generated. Okay. But at this point, the return or even the transmitted return signal that follow the Gaussian shape. Okay. It takes time to achieve VTH level. That time is over here. Okay. Then we can see that this is a correction time TC that has to be applied. Okay. Further, what we can identify, we can also identify the peak level. So when this signal attain the peak, that is time TR. Okay. So it is also recorded. And rather than talking about in VTH, we write in terms of power, PTH, threshold power. And this is peak power. Okay. So the correction applied TC, it is equal to, okay, tell me what it should be. Just think about it logically. Like we are going to write TC in terms of P peak, PTH and TR. If you see over here, this particular shape has P peak and TR. Okay. If you approximate it as a triangle, okay. If you approximate it as a triangle, then what it should be? These two are the similar triangles. Can we see? Can we say this?
P upon TR into VTH.
क्या बता रहा हूँ ये? TC is equal to
So
see,
TC equal to P upon TR into VTH.
2T कहाँ से आ जाएगा भाई? Just see. One label we are considering this, another we are considering this. Okay. So TC is related with this power, no? This end. So this is TC and this is PTH. Okay. So TC divided by PTH. It is equal to, now you consider the second one. Second one is this length, that is TR. So TR. And what is this length? That is TR divided by P peak. Okay. So if you simplify this equation 1, so from equation 1, you can write the correction that has to be applied, TC is equal to P peak into TR. Please note it down in your notebook. Why I'm considering P peak? Because P peak is identified by the receiver, peak level. Okay, so peak level can be identified, and at what time this peak level is achieved, this TR time is known. So P peak is known, TR is known, and PTH is already there. It is already chosen before the analysis. Okay, so PTH is the fixed threshold value, it is chosen. So what you need to identify when this signal is received at the receiver, you need to just identify at what particular TR time this P peak is achieved. PTH is already known, you can calculate TC. Okay, so meaning is that at the peak power, at the peak, that time TR is identified by the receiver and TC correction is applied. Take your time and note down the entire things, entire this concept which we have discussed. So you can start from this constant fraction method. Okay. Then the range walk limitation that we have, how it can be eliminated using this concept that the correction TC has to be applied, and TC is computed in terms of selected threshold power PTH, peak power in the return signal, as well as what is the time TR at which that peak power is obtained. Subham, could you please unmute?
Yes, sir.
Is there any doubt?
सर एक बार देख रहे हैं सर.
Hello. Subham, unmute.
Yes, sir. Sir,
No,
Shubham.
I think no. I was talking with Shivam, I think. Okay.
Okay.
Shivam,
Yes,
unmute. What you told?
हाँ सर अभी एक बार रिवाइज कर रहे हैं सर.
ठीक, good. All of you kindly go through that, because see, now I'm going to start the new chapter. Okay. Okay. So now we are going to start discussion on geolocation. Okay. So till now we have already discussed about the ranging principles, how the range is computed. Okay. And we have also discussed about how the power received at the receiver is calculated in terms of transmitted power, atmospheric parameters, reflectance of the material, okay, the target point, and the footprint size, etc. Okay, so the radiometric analysis we have already done, and we have already performed analysis in terms of like how to calculate range from a laser source to the target point. Okay, and when we were discussing about laser scanning from the moving platform. Okay, so laser scanning from the moving platform. What we need in addition with the laser scanner? We need laser scanner unit. Plus we require positioning and orientation system POS. Okay. And the individual data collected by laser scanner unit, in the POS we have GNSS plus IMU. Data of IMU, GNSS, they are combined together to geolocate. Meaning of geolocation is, let's say this is the target point P. Okay. And this target point is somewhere on the Earth's surface. Let's say it is positioned over here. So this target point is over here, somewhere here, the aircraft is flying. So the range is calculated with a scan angle. So let's say T is equal to T1, a laser pulse is transmitted. So corresponding to that R1 and theta1 is calculated. Okay. It is combined with the data of GNSS plus IMU at time T1. Okay. And this point coordinate is measured in global coordinate system. Okay. That is X, Y, and Z. So this process is termed as geolocation. And the geolocation process involved rotation and translation of vector. So before discussing like how the raw measurement that is collected by LiDAR system is combined together and the vector is rotated and translated to convert a target point coordinate from laser scanner coordinate system to this global coordinate system, we need to discuss the aspect of rotation and translation of vector from the vector algebra aspect and coordinate geometry aspect. Okay.
Sir, what is full form of IMU?
Inertial measurement unit.
Okay, sir.
I have already told earlier, I think. So this IMU and INS2 terminology are used. The functionality are same. So IMU stands for inertial measurement unit. Okay, and INS is inertial navigation system. Okay. So we'll start discussing about the translation of vector first. It's not translation. First, we'll start with the rotation, then we'll come to translation. Rotation of vector. Okay. So let's say a coordinate system is given. X, X, Y, and Z. This coordinate system is given. Okay. And somewhere in the 3D space, we have a point P. So in this coordinate system, the vector OP, represents what? This vector OP represent where the point P is located in the 3D space of XYZ coordinate system. Okay. So this vector OP can be represented as X component. Sorry. It's XOP plus Y component of vector OP plus Z component of vector OP. So for the simplicity, rather than 3D, we start discussing with 2D. Okay. So rotation in 2D. So this OP vector, if you do, we can project it, and this is given as XOP, and this is given as YOP. Okay. Now let's say this coordinate system changes by the rotating. We can consider this y-axis. Okay. By rotating about, we consider it's a right-handed coordinate system. So z-axis is considered as it's coming out of the page. Okay. So if you use right-hand thumb rule, so your thumb indicate the upward direction and it gives us the z-axis direction. Okay. So about z-axis, if you rotate this coordinate system, and we have a new coordinate system, that is X new. Here you can see this OP new. So XN and this is YN. So the coordinate system changes from the original one by rotating about z-axis. And this rotation angle is theta, okay, in anti-clockwise direction. Okay. Now how this vector OP is calculated in a XY coordinate system by using XOP and YOP, what it will be in a new coordinate system, that is X and YN. So this OP new will be equal to XOPN I cap, that is unit vector along xn direction, while it will be YOPN. How we calculated XOPN and YOPN, that is projection on xn axis and yn axis, using the value of XOP, YOP and angle theta. Just see how we can do it. So it can be done. Consider this. So this is the diagonal. This is 90 degree and this is 90 degrees. Okay. So the this diagonal XOP can be projected on this axis and this axis using angle theta. Okay. So if we see the projection of XOP projection on xn, what it will be? It is equal to XOP cos theta. Okay. Now XOP projection on, now it will be minus yn axis and it is equal to XOP sin theta, because this angle is theta. Similarly, this XYP is also projected on xn axis and yn axis. XOP YOP projection on xn, what it will be? This is also angle theta. So this will be XOP sin theta. Okay, now XOP projection on, now it's not minus yn, it's plus yn, and it is equal to XOP cos theta. Okay, now you need to see that xn, what is the total? You need to add a component along xn. So after projection, xn component is equal to, let's say this is equation 1, 2, 3 and 4. Okay. So considering 1 and 3, equation 1 and 3, xn is equal to XOP cos theta plus YOP sin theta. Okay. Now use 2 and 4. Using 2 and 4, you will calculate yn, and yn is equal to minus XOP sin theta plus YOP cos theta. Kindly note it down. Please make a note on this. Kindly see this derivation very carefully and note it down in your notebook. Okay, if you have completed this, I hope you have revised it. So kindly do the similar calculation for rotation about x-axis and rotation about y-axis. In this case, what we have derived, when we rotate in a anti-clockwise direction by angle theta about z-axis, so xn and yn can be written in terms of xop and yop. Okay. Do the similar calculation by changing the axis about which we are doing the rotation. Now you select x-axis as a rotational axis and y-axis as a rotational axis and do the same derivation. I will discuss with you.
Excuse me, sir.
सुमित बताओ।
सर ये जो वैल्यू निकली है xn एंड yn फाइनल में, सर ये वही xopn i कैप है ना जो हम फाइंड कर रहे थे। i कैप हटा दें तो xopn है ना।
देखो इसमें ये है ना कि opn is the vector in xy coordinate system. Fine.
Yes sir.
See, first of all, the original vector in xy coordinate system is op. Okay. Now the same vector op, when coordinate system changes, this vector will change. Fine. So in x and yn coordinate system, this become opn. Okay. Now the projection on x and y axes will change. You can see over here the projection will change. So this xn and yn that we calculate over here. Let's see. So this xn and yn are the new values on in x and yn coordinate system, and they are coefficients of along this I and j. So it can be written this. Okay, fine. Don't call it this xn. I'm talking about xopn. You can say this xn is equivalent to xopn. I think you have this confusion.
Yes sir. Yes sir. Now this was only this was thing I was asking.
Yeah. And see further, these equation can be written in terms of matrix. Just see. So this x opn and y opn, you can write it as a column vector. It is equal to cos theta, sin theta, and this will be minus sin theta and cos theta, and multiply it by xop and yop. So in xy coordinate system, xop and yop are the projection of vector op on x-axis and y-axis. If you rotate the coordinate system, to change the xy coordinate system by rotating anti-clockwise direction with angle theta, then this xy coordinate system you have a new coordinate system, that is xn and yn. So in new coordinate system, the projection will be xop and yop corresponding to same. This is same. This is not going to be changed. The p will be same, origin will be same. Only the direction of axes are changed. So what will happen? Just see. Now the projection will be this, while in the previous case projection was this. In this case, so what is actually happening? Along xo, the o along the xn axis, this distance is increases. So this distance is increased, and it is evident over here xn, that is you are going to add the two component. Okay, while at the same time just see that this will decrease, this length is decreased, and you can see over here it's minus xop sin theta plus xop cos theta. In the same way, you can do the derivation for rotating the vector along x-axis and y-axis as well, and derive this matrix. This is called as rotation matrix, this section. So this is considered as rotation matrix when you rotate about z-axis. It is in 2-dimension, 2D analysis we are doing. We can extend it into 3D as well. Okay, so how many of you have completed this rotation matrix when we rotate this coordinate system about x-axis and y-axis? Okay, good. So Sumit has completed. What's about others?